Hello everyone, I'm Zeng Cheng. We'll study the last part of this course together. In our course, lots of mathematics will be involved. However, math is just the same as words. It's a tool to express ideas. Therefore, in our course, I'll try as much as possible to show the ideas expressed by the mathematics to you. Hello everybody. We'll introduce the signal flow graph and its properties in this lesson. After the introduction of some basic concepts about the signal flow graph, we'll introduce the main terms and main properties of signal flow graph systematically. Firstly, let's talk about what a signal flow graph looks like. The signal flow graph can be regarded as a compact representation of the S-domain or Z-domain block diagram. But it is more precise and more formal than the block diagram. For example, such a system block diagram can be equivalently represented by a signal flow graph. In the signal flow graph, nodes and branch are its basic components. The node represents a signal or variable. The branch is a line segment with a direction between two nodes, which denotes the transmission route of the signal. For example, this is a typical signal flow graph. We'll introduce some basic terms of signal flow graph based on this plot. Let's classify the nodes in the signal flow graph first. One is called input node or source node, which is the node with only output branch. In general, it represents the input signal in the signal flow graph. For example, a node like this one. The second type is the output node or sink node, which is a node with only input branch and represents the output signal in general. For example, this node. The third type is the mixed node, which has both input and output branches, such as these nodes in the figure. All of them are mixed nodes. Next, let's pay attention to the branch and path. Branch has been mentioned above. Is a unidirectional line segment connecting two nodes. The arrow on the branch indicates the transmission direction of the signal, while the symbols labeled near the arrow denotes the system function between these two nodes, which is also called transfer function or branch gain. A path is usually a route composed of several branches. For example, this path. It's a route originating from one node, traversing all connected nodes along the branch directions, and finally terminating in a node. Note that the path can only be formed along the direction of the arrow. The product of the gains of all branches it passes by is called path gain. According to its structure, path can be categorized into several types. The first one is open path. It's a path that traverses any node no more than once, just like the path we saw before. Especially, an open path from the source node to the sink node is called forward path. Accordingly, the product of gains of all branches in the forward path is called forward path gain. In a signal flow graph, there are probably several forward paths. For example, in addition to this forward path, there is another forward path, which is also an open path from the source to the sink. Contrary to open path, the closed path is a route originating and terminating in the same node. Besides this originating terminating node, it will not traverse any other node twice. A closed path is also called a loop. For example, such a path originating from this node, passing through A, B, F in sequence, and returning to the originating node finally forms a loop. The product of gains of all branches in a loop is called a loop gain. Loop is a very important concept in the signal flow graph. According to its characteristics, loops may belong to different categories. One is self-loop, which is a loop with only one node and one branch. For example, the loop originating from this node, passing through G and then returning to the same node is a self-loop. Another is non-touching loop. If two or more loops have no common node, then we call them non-touching loops. For example, these two loops are non-touching loops. Now, let's make a list of some basic properties of the signal flow graph. Firstly, the branch is unidirectional. As mentioned earlier, the branch has its own direction. The signal in the input node of a branch is the product of the input signal and the branch gain. Secondly, node sum all inputs. A node may have several input branches and several output branches. The node will sum the outcomes of all its input branches firstly, then use the summation to drive all its output branches, which means output follows summation. For example, the node x4, it sums the outcomes of 3 input branches and then drives these 2 output branches respectively with the summation. The third one is the transposition invariance property of the signal flow graph. When a signal flow graph is transposed, the signal function it represented remains unchanged. However, what does the transposition mean? The transposition is to reverse the directions of all branches in the signal flow graph, meanwhile exchange its source and sink nodes. Such an operation is called signal flow graph transposition. Taking the signal flow graph we introduced above as an example, we can see its input node, its output node, and the original directions of its branches. After transposition, the directions of all its branches are reversed. After direction reversion, the original input node becomes an output node, and the original output node becomes an input node. This is the signal flow graph transposed from the above one. Of course, for convenience, we usually turn over the transposed signal flow graph so as to put the input node on the left and the output node on the right. This is the signal flow graph after turning over. According to the transposed property of the signal flow graph, these signal flow graphs, including those before and after transposition, have the same system function from their input to output. Finally, let's make a summary of this lesson. Firstly, the signal flow graph can be regarded as a compact and precise form of the S-domain or Z-domain block diagram. Secondly, nodes and branches are the basic components of a signal flow graph. Thirdly, paths and loops are bases for the analysis and simplification of the signal flow graph, which we will discuss next. Fourthly, several basic properties of introduced. And that is the end of this lesson. Bye.